Today we'll be talking about properties of exponents applied to rational exponents. So by the end of the lesson today, you should be able to apply all those properties that we talked about with whole number exponents with rational exponents. Here's a list of all the properties. So remember, when we multiply with the same base, we add the exponents. Power to a power, we multiply the exponents. Multiple bases, power to a power, we distribute the exponent. Negative exponents move around the fraction. Division we subtract, and division within power to a power we also distribute. So let's see how this works with those fraction exponents. So here we have a base. Our base is 7 and our exponents are 1/4 and 1/2. So we're doing multiplication with the same base, so we need to add those exponents. So we get 7 to the 1/4 power plus 1/2 power. And remember, with fractions we need a common denominator. So 1/4 plus 1/2. Our common denominator is 4. So to make the right hand side 1/2, 4, I have to multiply the top and bottom by 2. So I get 1/4 plus 2/4, and when I add that together I get 3/4. So my exponent on the 7 is 3/4. So here we have power to a power. Remember, when we have a power to a power, we distribute that 2 onto both exponents, onto both bases. Our two bases are 6 and 4. So we get 6 to the 1/2 times 2 times 4 to the 1/3 times 2. So remember that 1/2 times 2 over 1, that's 1. So we just get 6 to the first power. And then 1/3 times 2 over 1, that's 2/3. Remember, we multiply across. So that's going to be times 4 to the 2/3 power. And remember, we cannot combine these bases together because this has an exponent of 2/3 and this has an exponent of 1. We cannot combine them together. So we get this. So here we have division with the power to a power. So remember, we distribute the 2. So we get 42, and then 1/3 times 2 over 6, 1/3 times 2. And we just did that 1/3 times 2. So we get 42 to the 2/3 power over 6 to the 2/3 power. See if we can simplify it, but there is no cube root. Remember, cube root of 42 or cube root of 6, so we cannot simplify it. We also cannot reduce that 42 and the 6 because they both have an exponent on it. So we leave it like that. Now when we have multiplication with these root bases and division with root bases, just like we had with just the square roots, we can multiply them if they're all under the square root, and we can divide them if they're all under the square root, and we can multiply if they're outside of the square root, or divide if they're outside of the square root. So if we look at the top one, I can multiply those two together, so we get the cube root of 12 times 18. But just like with square roots, we need to simplify. But we've got the cube root this time. So last time when it was a square root, we looked for pairs. This time we're going to look for threes, 3 numbers that are the same. So if we look at 12, 12 is 2 times 6, and 6 is 2 times 3. So here are the ends of our branches for that. Then we tried the 18, that's 6 and 3. There's the end of the branch. And then 6 is 2 and 3. And now, let's change our colors. We look for threes. So I have 2 2s and 3 2s. So that goes on the outside. And then I have 1 3 and 2 3s all together. So that also goes on the outside. So 2 times 3, and we get 6. There are no single numbers, so we have nothing still left under the cube root. So let's try now with division. So the 4th root of 80 and the 4th root of 5, they're both under the square root sign, so I can combine them together and divide them. 80 divided by 5 is 16. And the 4th root of 16, remember 16 is 4 times 4. 2 and 2, 2 and 2, so The fourth root of 16 is 2. So pause the video and try this one on your own. So we need to simplify the third root of 135. So we need to factor that 135. 135 is 5 times 27. So there's an end of our branch. 27 is 3 and 9. So there's another end of our branch. 9 is 3 and 3. So here are all the ends of our branches. Now, because we're looking for the cube root, let's find sets of 3. So we have 3 3s here. So that number goes on the outside. And then we have a single number here, 5, so that one is going to stay under the cube root. Like that. And don't forget that 3 right there in the root sign, because then I will not know if you understand that that's the cube root or not. Now this is probably the most difficult concept to understand. So I had the fifth root of 7 and the fifth root of 8. I can't divide 7 and 8. I can't reduce it. There's nothing really I can do division-wise or fraction-wise. But remember from before, we cannot have any kind of roots in the denominator. So let's see what this looks like when we factor it out. 8 is 2 times 2 times 2. So in order for me to eliminate that square root on the bottom, I need 2 more 2's in order to have a set of 5. So I need to rationalize the denominator by multiplying under the square root with 2 more 2's. And whatever I do to the bottom, I have to do to the top. Because you see, now I have 5 2's. Now I can bring that 2 on the outside, and I no longer have a square root or any kind of root in the denominator. If I look at the top one, that's 7 times 2, which is 14, times another 2, that's 38. So we get the fifth root of 38 over 2. Remember, we do not want roots in the denominator. So let's look at this one. We want to simplify this problem right here. So we need to find all the sets of 3 within 64y to the 6. So 64 is 4 times 16, and 16 is 4 times 4. And you could keep going if you would like, but we already have a set of 3 right there. So we know that the 4 is going to go outside. Then we look at the y to the 6, that's 1, 2, 3, 4, 5, 6. That's what that means. So I have a set of 3 y's here and then another set of 3 y's here. So one of those y's goes on the outside, another of those y's goes on the outside, and I have no singles. So that is 4y squared. So now we're going to simplify these radicals with not just numbers, but also with variables. So why don't you pause the video and try this one yourself. Okay, so we have multiplication inside, power to a power, so I distribute that 1/3. So I get 27 to the 1/3 power. I get p to the 3 times 1/3. I get q to the 12th times 1/3. This is the cube root of 27, which is 3. 3 times 1/3, 3 over 1 times 1/3, that's just 1, so we get p. 12 times 1/3, 12 over 1 times 1/3 is 12 over 3, which is 4. So we get 3pq to the 4th. So same thing here. This fourth root, right, means that's the 1/4 power. So we can think of this like m to the 4th, n to the 8th to the 1/4 power, and then distribute the exponent that way. Or we can think of it as the fourth root of m to the 4th is m times m times m times m. n to the 8th is n times 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 n, and find all of our sets of 4. I have a set of 4 m's here, and then I have 2 sets of n's there, so that's going to be m over n squared. Now here's where we get a little tricky, and we had difficulty with these types of problems with whole numbers, so of course we're going to have some difficulty, and we're going to need to work really hard to understand with fraction exponents. So let's look at this problem. Remember, we want only positive exponents, we want no parentheses, no zero exponents, and only one base represented. Okay, so if we look at the 14 and the 2, they don't have any exponents, so that's just a fraction, so I can simplify that. 2 goes into 14 7 times, so I'm going to have a 7. If I look at the x's, I have one on the top and one on the bottom, so remember that when we have division with the same base, we subtract the exponents. So I get x, the top x has an exponent of 1, and then subtract the bottom exponent, and 1 minus 3/4 is 1/4. And that exponent is positive, so that thing gets to go on the top. The y, there's only one y, so we get y to the 1/3. And then the z is negative, so that needs to move up to the top. So we get 7x to the 1/4, y to the 1/3, z to the 6th. So why don't you pause the video and try this one yourself. Okay, so let's try these a couple of different ways. We could factor it all out, which is going to be a little messy, but still get you the correct answer. So 4 is 2 times 2. 8 to the a is 1, 2, 3, 4, 5, 6, 7, 8. And then b is 14. And then c to the 5th. Right. Now we find our sets of 5 because we're doing the 5th root. 2 times 2, no more 2's. A's, I've got 1, 2, 3, 4, 5, and then 3 A's left over. I have 1, 2, 3, 4, 5, 6, oh sorry, let's try that again. 1, 2, 3, 4, 5 B's here, and then 1, 2, 3, 4, 5 B's here with 4 B's left over, and then I have 5 C's, so all the red go on the outside. 1 A, 2 B's, and 1 C. And everything else is left underneath. So 2 times 2 is 4, A to the 3rd, 1, 2, 3, B to the 4th. Another way you could think about this is, essentially what I did was I took this and divided it into this. And that however many times it goes in evenly is the exponents of these out here, right? 5 into 8 goes once, 5 into 14 goes twice, 5 into 5 goes once, right? This is an exponent of 1. And the remainder is what stays underneath the square root, right? So 5 into 8 goes once with 3 left over. 5 into 14 goes twice with 4 left over. And then 5 goes into 5 once with nothing left over, which is why we have no C. So depending on how you want to think about it is completely up to you. Remember, in my class, I don't care how you get to the right answer as long as it makes sense. And so here's the last one. So the 3rd root of x, can't factor that. Y to the 8th, 1, 2, 3, 4, 5, 6, 7, 8. I have a set of 3 y's here, another set of 3 y's here. So those two can move to the outside. But I still have 2 y's left on the bottom. And remember, we cannot have square roots in the denominator, any kind of roots in the denominator. So in order to eliminate this root, I need 3 y's and I only have 2, so I need 1 more. Now I have a set of 3 that can move to the outside. So I have the 3rd root of xy all over y cubed, because remember I already have a y squared here. So here are some practice problems. You can go ahead and try some on your own. Tomorrow we'll do some in class and you'll be able to take a homework quiz.